All right, let's look at section 4.4, which is on source transformations. So we can transform an independent voltage source that is in series with a resistor to a current source in parallel with a resistor. And this is going to come in useful in a couple more sections. So we can take an independent voltage source in series with some R and transform it, we can go either way, to a current source in parallel with that same R using Ohm's law. Vs equals IR, ISR. So if we have this and we're going this way, then we just need to multiply these two together to get our voltage source. If we have our voltage source, we're going to the current, then we need to divide by our resistance. So we can go back and forth. And this circuit and this circuit will provide the same power, the same current, the same voltage to whatever is on the other side of it. And that's really all there is to it. There's not a lot to source transformations, so we can wrap up that section and move on to Thevenin's theorem. So Thevenin's theorem is a bit confusing. The first time people see Thevenin's theorem, they get very stressed out about it. So just follow along with all the examples you can watch. I'll provide at least 2 on top of this lecture. So section 4.5 is on Thevenin's theorem. And this is the idea that we can take any linear circuit we have a circuit here, and it's connected to some load. Don't know what it is, don't care, does not matter. But this is providing some voltage and some current, right? The circuit to the load. We can transform this into a single independent voltage source in series with a resistor and provide the same voltage and current to that load. So we're going to take any linear circuit and reduce it down to an R Thevenin and a V Thevenin. So it won't do that until the next video, which is the example problems. But wanted to give you the basic idea of what Thevenin's theorem is. We also sometimes call V Thevenin V open circuit, because that's how we find it. So when we have our linear circuit, a linear circuit is a circuit that has only linear elements. So elements that follow Ohm's law, V equals IR. It's going to be everything you do in circuits 1 and 2. You don't deal with nonlinear circuits until electronics. So any circuit that you're learning in this class, you can do Thevenin's theorem on. So if you knock off the load, open right here, and find that voltage, that is V Thevenin. That's the voltage we're providing. So we sometimes call V Thevenin V open circuit. R Thevenin is also an input resistance, so looking into our load. And the way that we do Thevenin's theorem is first we find V Thevenin by opening our desired location. And then we find R Thevenin by removing our load and deactivating, which we know how to do, independent sources. So again, Thevenin's theorem is one of those you really need to see to understand. So that'll be the end of this video, and I encourage you to watch the next 4 example problems on Thevenin's